Yeah, so I think you should see an icon showing we are recording. I think it's a red icon. Yeah. So yeah, so it's on now. So yeah, thank you everyone, for those of you who have managed to joining, or for those who are on YouTube. I know you would have liked to join us today, but you couldn't. I'm sorry, by the way, for the video. I put it off because of my bandwidth, just to make it easy for the connection. Yeah. So welcome to this exciting course on software verification. This is actually the first, let's say, practical or applied course in the community, because so far in quantumformalism.com community, we've been focused mostly on mathematics, abstract mathematical structures and so on. In fact, this course wasn't meant to be for under the quantumformalism.com community. It was meant to be under another community that we run called homotopicminds.com, which is for mathematicians, pure mathematicians seeking to transition into industry. But then I realized that many people from quantum formalism community are coming from programming background. So this will be very, very useful course for them. So that's one of the reasons we decided to put this course under the quantum formalism community. I invited everyone else, obviously, from Homotopic Minds and other from wider network of our company, because I think it's going to be very interesting, especially people coming from programming background. How do you ensure? How do you certify that? Software correctness. This is very, very, very important. Yeah. So I couldn't be more happier than having our friend here, Benedict Ahrens. We've been discussing about this course, I think, since last year. It finally happened. It's okay. It's going to happen anyway. Yeah. So Benedict is an assistant professor in the programming languages group at Delft University. For those of you, I'm sure a lot of you on quantumformalism.com, you know the Delft University in Netherlands, because they are very active in the quantum space, quantum technology space. So Benedict also has other appointments, like he's, for example, he's a fellow in School of Computer Science at University of Birmingham, UK. His research interest includes semantics of programming languages, logic and type theory, in particular homotopic type theory. This is also another course that we should discuss with him later at some time about a course on homotopic type theory, because this is very, very, very interesting stuff. I remember the first time I heard about him, I think it was a talk by Vladimir Vovedovsky. I don't know if I'm pronouncing his name properly. He's now passed away. He's a field medalist. Yeah. So anyway, yeah, so you will be in a very, 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 very good hands. I'm pretty sure, Benedict will, give you a very, very smooth introduction to this very interesting topic, and useful as well in your career. So without further ado, I will pass on to Benedict. Maybe he can make a bit comment about, first of all, introduce himself.
Yeah.
And then, take over about the course stuff, and then we will open up for any questions. And yeah, we take it from there. Thank you so much again for being here. And Benedict, the floor is yours.
Thank you very much for the introduction. Yeah, I'm Benedict. I live in Delft now. Before that, I lived in Birmingham, and before that, I lived in the US and in France. And software verification is a course that I teach also at TU Delft. And I thought it could be a very nice course for people who want to transition, for instance, from academia to industry. And Bombardier suggested that I teach it here. And the goal of this session is for me to explain to you a little bit what we're going to do for you to learn about software verification. Okay. So at any moment, if you have any questions, just shout out, and yeah, we will discuss your question. Maybe I should share my screen and then show you a little bit what how we're going to learn together. So I think I can maybe share my screen here.
Yeah, you do have permission, I believe. Yeah.
Okay.
Let's see.
Fantastic.
Because you are co-host. Yeah.
Okay. Can you see my screen now?
Yes.
Yes. Okay, fantastic. So I don't know if I want to start by looking at the GitHub repository that we have set up at Bombardier, and I filled it with some content. This is the GitHub repository, which is sort of the entry point to this course and to the course material. The URL is github.com/quantumformalism/software verification. So you can go there right now if you want, going along with me. And my goal is that all the important information is on the first page here, which is the README markdown file. This is, yeah, I'm planning to have all the important information on this page. And if there is some information missing from this page, then that's a bug. And then I would ask you to let me know so that I can put that information here. Okay. So from this page, you should be able to get all the information that you need for the course. I've put a little bit of text onto this page. What's the motivation for this course? Well, what we want is that software doesn't crash. That's very important. And also that it does the correct thing. It's not trivial to specify what it means for software to be correct. And this will be part of the contents of the course. What does it mean for a software, an algorithm to be correct? How do I specify correctness? And then how do I prove correctness? In order to specify and prove correctness, we will use logic, of course. So logic is an extremely important ingredient to this course. And indeed, logic will be the first topic that we cover. And in particular, we will cover propositional logic and predicate logic, aka first order logic, before actually coming then to the sort of the meat of the course when we do functional programming and verification of functional programs. Okay, what should I say? So you can read this motivation here. I'll make it small again. You can read it by yourself. What is important maybe is the mode of communication. Bombardier set up a Zulip chat for us that you can go to. After making an account. So here, what is important is that you can. It's organized. It's organized in streams. The messages on the threads. So we have streams, and in each stream separately we have topics. So when I want to write a new message, I can go down here and write a new topic. That's like the thread. That's like the subject line of an email thread, and then you can insert your message down here. And yeah, so I think this is a very good way of organizing communication between many people, and hopefully this will be a useful resource that accompanies the course.
Yeah, I just want to comment. Actually, I noticed this functionality because originally we wanted to do on Discord, but then Benedict convinced me, and I'm glad because I think on Discord is it is a little bit hassle, not just the small stuff like the support for LaTeX and so on, but this level of organizing the chat is much more cleaner. Yeah, so I think it's much more useful, especially in doing a course of this nature. Yeah. So yeah. Sorry. Yeah, hand over to you now.
I got a question, Benedict. What is swimming turtles?
What is swimming turtles here? Okay, so this is one topic that is being discussed. It's always there. It's present there already in the beginning when you set up a new server like this, a Zulip server. I think it's just a cute turtle. There's no meaning to it. It doesn't have. It's not specific to the content of this course.
Okay, thank you.
So flying pigeons, we can make a new topic called flying pigeons, and I can say, hi, everyone. And now you see here on the left-hand side, there is a new thread or a new topic called flying pigeons. Okay, next to the swimming turtles. So you can switch here between different streams, and within each stream you have a topic. You have a list of topics. And importantly, one can subscribe to different courses or not, to different streams or not. Anyway, try to get used to this tool. I think a lot of scientific communities use this tool. For instance, there's also leanprover.zulipchat.com. Leanprover is the tool, the computer tool that we are going to use, and there's also and they have their separate Zulip server where people ask a lot of questions. So I think it's a very useful software to be familiar with. Okay. Do you have any more questions about this?
Yeah, I just want to add one comment on that. I think it's very useful. One of the reasons for Zulip as well is these other communities that are relevant to the course, like the Lean Theorem Prover community, because at the end of it, I think we'll touch this at some point. There will be like a project part of the course. So you might want to implement your project with Lean or some other stuff that communities that have some other software communities that have a thing on Zulip. So yeah
exactly. So I will be talking about computer proof assistants, which are computer programs that can check the correctness of mathematical proofs and of logical reasoning. And all these communities have their own Zulip server. It's kind of an industry standard now. So we are just following the lead of other communities. Okay. Going back to this, to our learning repository. So please do join the chat. And then I want to say a few things about the course. What are we going to do? Well, this is what I want to discuss with you today. Propositional logic is the first scientific topic. Propositional logic is a logic where we talk about statements. It's a simple kind of logic in the sense that it doesn't use existential or universal quantification. The only constructions that we can use is disjunction, so or, and conjunction, and implication. So these are the mathematical statements that or the logical statements that we are considering are built from these constructions. And then we will see how to prove a statement written in propositional logic. And afterwards, we discuss predicate logic, which is sort of an extension of propositional logic by quantifiers, namely existential quantification and universal quantification. So in predicate logic, we can say statements such as, for all natural numbers n, 2 times n is an even number. And there we have a quantification, a universal quantification over natural numbers. Once we have done this, we will learn how to do functional programming in a computer proof assistant, and we will learn how to verify such functional programs. So, oops, this is planning. So, functional programming in a computer proof assistant will look similar to functional programming in Haskell and OCaml. But in addition to that, there will be facilities to write mathematical statements about the programs that we program. And there's also facility then to prove the mathematical statements. We will see an example of that in just a second. So importantly, the whole course will take place in what is called a computer-proof assistant. And before, maybe instead of talking about it, let me just briefly show you an example. And for this example, I will go to one of the course materials that we have down here. We have a list of course materials. There will be 2 books that we will be using. The book first called Logic and Proof, and then the course in the book called Logical Verification. So let me go to this, just for as an example. Let me go to this proof, to this book, and I will show you what a computer-proof assistant looks like. So what is cool about this computer-proof assistant is that it runs in the browser. Can you see my browser now? Is it big enough?
Yeah.
Yeah, okay. It takes a while to load. It's still busy loading, so maybe my connection is not very fast here. Anyway, what you see here is a computer-proof assistant. It has an input field on the... Do you see my mouse pointer, by the way, or not?
Move it real quick. Yes, we can see it.
Okay, perfect. So this computer-proof assistant is very simple in the way it works. It has an input field, which is on the left of the screen, and it has an output field, which is on the right of the screen. Okay, so whatever we type into the left-hand field is analyzed and is read and analyzed by Lean, which is the computer-proof assistant we are going to use. And then on the right-hand side, we get output, sort of a response from the computer-proof assistant. Here, what we are doing is we are defining, or we are declaring to have 3 propositions, A, B, and C. And then we write a logical formula that is A and not B implies C. Okay? And what we do is we ask Lean to check if this is a valid formula or valid proposition. And Lean says, when we put the cursor into this line, Lean says on the right-hand side, well, A and not B implies C is a proposition. So this colon is to be read as the thing on the left-hand side is a thing of the type right-hand side. So this term here is a term of type proposition. Okay. For now, this is just gibberish to you. But what I want just to show is that this is really a tool that is very simple to use. And what happens if I do something silly? If I just write A and I forget to put something here on the right-hand side of the and, then it says invalid expression, unexpected token, because this expression here that I've written A and is not complete yet. Yeah. Or if I say A and 5, then it will say, it will give an error message that is kind of incomprehensible for now, and we will learn how to understand these error messages. 5 plus B, that would also be, well, let me just find something that gives an interesting, no, they're all these error messages are kind of difficult to decipher now, but hopefully by the end of the course you will understand them. Okay, let me go back to the course plan. I briefly showed you something about this first book that we will be using, and this will be this is this book here. It's an online book, freely available, and it's essentially an introduction to logic and proof. So it starts with chapters on propositional logic and how to do propositional logic in the computer-proof assistant Lean, and then later it also does. From here on, predicate logic. If I can mark this, I don't know why this doesn't work. Yeah, here. So we will study the chapters 1 to 9 from this book to learn about, or to get up to speed about propositional and predicate logic. And once we have understood propositional and predicate logic, we will go to a different book called Logical Verification, which is a book written by Jasmine Blanchette, who at some point was at, or until recently was at Freie Universität Amsterdam, and has now moved to Munich. And we'll be using his code materials that are also freely available online. And we will study, I think, the first 5 chapters from this book about how to write definitions and statements, how to do proofs in backward and forward style, which are 2 proof styles in a computer proof assistant. Then we will learn about functional programming, and so we will learn how to write programs on lists and on other data types. And then we will learn how to write inductive predicates and proof predicates that make statements about our programs. So we will, from this book, we will cover about the first third or so, a bit more. So I invite you to study both books and both materials before we get started. You can take a look and glimpse into this material. And then there are some additional resources here that I point to again. There's Lean in the browser, which is just a link to the computer proof assistant, which runs in the browser, but it also runs on your computer, so you can install it yourself. Running it in the browser is very good in the beginning, but for serious work, you will want to install the tool on your computer. And there are installation instructions for Lean also in this, a link to that in the README. There's also a link to a Lean tutorial that you can look at. And here, a link to a book that is called Concrete Semantics, which is, I think, covers covers a lot of material, in particular semantics of imperative programming languages, but using a different computer proof assistant. But you could also always take a look into this book. It's also freely available on the web. And finally, another link to our Zulip server. Okay, so the way are there any questions before I continue about this material? No? Not?
The software, the software we're going to be using, how do we access that? Is that like a download install, or is it off a website?
If you go to the installation instructions,
okay,
it will. So here you can choose your operating system. Let's say you're using Debian, and you can unfold these instructions here. And here, it gives you a long command to run, and then that will include downloading some software onto your computer and installing it.
Okay. Thanks.
If you have any difficulties with the installation, which happens very frequently, it's the software is not as easy to install as just downloading a file and double-clicking on it or something. But it should be this is relatively well tested, I think. But still, there can always be errors and problems that arise. Then I would invite you to go to the Zulip and start a thread about copying the error message that you see and asking for advice, for help. Okay?
Okay, great. Thank you.
Thank you for the question. Are there any other questions?
I don't see any other questions on the chat, unless someone... No.
Right. No, I'm not seeing anything in the chat. Good.
Okay.
Then if I go back to the README, this is maybe the important part, which is not filled yet. This is the plan. So what I'm planning to do is teach in a flipped classroom style. So what this means is that I will, for each week that we meet, I will write instructions, say, with instructions for how you can prepare for our synchronous sessions. And these instructions will include pointer to a book chapter, pointer to a video that goes with the book chapter, all the possibly if there is a video that I can point to, and pointers to problems and solutions that you should or could look into and study before we meet. And then in the synchronous meeting, I suggest that you guys present the solutions that you have come up with, the problems that you have encountered, and possibly we can discuss any questions that you have that go beyond the material of the corresponding section and the problems. Or if you have questions about competing solutions, which one is better, what is best practice, and so on, then this could all be discussed in the joint synchronous session. Yeah, we don't have that much time together, so it's really important that you prepare for each meeting by reading the section or sections that I point to, and trying to solve the exercises. And it would be very good if when you have difficulty with a specific exercise, you can of course wait until the session to discuss it. That's fine. But you could also go to the SULIP and ask your question here, and then you can already start a discussion. And maybe this will help you get unblocked way before we meet, and you're not losing time by being stuck on a certain problem. Okay, so I think of course I want the synchronous sessions to be useful, and we will have something to discuss, but it's also good to not get stuck, and so not wait for the synchronous session, but instead be more proactive and ask something here on the SULIP, for instance, to get unstuck.
I just want to add one comment. This we are trialing this. First of all, Benedict has trialed this approach successfully in his courses at the university, and it also overlaps with some of the stuff that our community we face, which is a lot of people have different commitments, so sometimes they cannot attend the live sessions, live lectures like FIX and so on. But at the same time, we want to motivate people to really, dive on into things. So to kind of give people this thing of empowering them to learn independently. So this was one of the greatest benefits that I think this approach can bring to this course. And we might, based on the thing of learnings that we get from this, we might extend this for our future courses, even the mathematical ones.
Yeah. So I've taught this course in a very similar setup at TU Delft, and I've had people who couldn't attend any of the live sessions, and they only studied the material and asked questions in our chat. And in the end, they learned enough to finish the project and even had very good results. Some of the students had a perfect mark, even though they could not come to a single session. Yeah. So it's the course essentially. It is designed such that it's possible. It could be possible at least to do it without participating in any of the synchronous sessions. Of course, if you can participate, then I encourage you to participate. But if that's not possible for you, then it should still be. I think it could still be possible for you to get a lot out of this course. Yeah, through asynchronous discussion via SULIP and through the learning materials. Okay, so here these links for now, they are just not working because I have not filled them in, but my plan is to give you for each week a very precise list of things to do to prepare, and in the best case to do this before we meet, and then let's discuss questions that arose while you were trying to solve exercises and so on. Okay. Do you have any questions regarding this setup?
Bob, you were going to say something. I know the thing, or was that? Do you want?
Yeah, look,
you want to
Ivan,
comment on anything?
yeah, okay. Yeah, what I want to say is, I've taken courses with this format before,
Mhm.
and they do work very well.
Okay.
That was the comment I was going to make. It's more of a compliment. That this is a good way to go.
I was expecting a but at the end of your sentence.
No.
Well,
If there's a but,
thank you for
that's
that.
good.
Bob. My heart was about to sink. I was like, no, I'm joking. Well, this is one of the things that we are trying to do in the community, as much as trying to bring on new courses and these things, but also innovate or try new ways of improving the delivery, the outcomes for the course, which is for people to learn. And the best way to do that is to learn something is actually to get involved with the hands-on and doing things. Just watching someone talk or doing things like how as we've been doing things, it can work for some people, those who like, but a lot of people then they just start to miss out. But this format motivates people to really take ownership of their learning, which is great.
Yeah. So I see my role as not being a teacher, but more of a learning assistant. Yeah. My goal is to get you unstuck when you're stuck, and to guide you in your learning. But I don't want to be called a teacher, because the important activity is not the teaching; it's the learning. Okay, I think. Oh yeah. Well, what is not mentioned yet in this README is the project that Bombardier has already mentioned. At the end of the 6 weeks, or I don't know, it depends. We might have to adapt the number of weeks of courses or of learning that we have to do before we are ready to tackle a project. So at the end, after the learning activities here, there will be a project that you can tackle that will be about implementing a program, a substantial program. I mean, it will not be enormous, but it will be more than a toy example, and proving it correct in a certain, whatever that means, correct. So part of the exercise will be to specify what correctness means, and then prove correctness of this program. And my plan is to have 3 different projects. One of them will have to do with an SM, or will be about a SAT solver, a satisfiability solver. One will be about type checking, and one will be sort of a small compiler for a language of arithmetic expressions. So this is information that is not yet on the README, and I will put it up when we approach that phase of the course.
Yeah, I just want to comment. This project stuff, in principle, this as it stands, because I know people will want to ask for certificates. By the way, my connection, is it breaking? I just noticed my video is on. Can you hear me properly?
Yeah, we heard you.
Yeah. Okay, so just a quick one. In principle, as it stands, for people to get certified, they need to deliver. They need to do a project work, either as a team or as individual.
Okay. Are there any questions about this stuff so far? Actually, I'm pretty much done with what I have to say. So I don't know if there's anything that you want to say, Bombardier, or if anybody else has any questions or comments, then now could be a good moment.
Yeah, Benedict. The content of your course reminds me a little bit of a course I took maybe 6 or 7 years ago that was offered on edX from University of Texas at Austin. It was called it was a linear algebra course. It was called Programming for Correctness. And it was very similar. We were using first order logic to validate like matrix multiplication routines and things like that. It sounds like what you're doing is a more general version of that. know if you know about those guys, Maggie Myers, Robert Vigin.
No,
no.
I don't. Sounds very interesting. Did you use automated theorem proving or interactive theorem proving?
We used an interactive piece of software that was not designed for mathematical theorems. It was just like a logic type program where if you type expressions, it would validate whether or not the expression was valid. But nothing as sophisticated as what you're showing us right now.
It sounds very interesting. If you have a link to that course, would you be willing to share it with me so that I can take a look at what you learned?
Sure. I got the edX cage here.
Maybe you can put the link onto the Zulip. That would be fantastic.
Oh, put on Zulip? Sure, no problem.
Yeah. Once you.
Or I can put in the chat, or I can put in the chat right now. It's up to you.
Well, the problem is that the chat will be lost, I think, for me at least.
Sounds good.
And the Zulip is there forever. I think.
Yeah, it's actually interesting, Bob, even from the other mathematical courses that we have in mind as well. So to see what the time, because that course was on linear algebra. Is that what you said?
Yeah, those two instructors basically they do linear algebra.
Okay.
Develop faster algorithms for like vector multiplication and those kind of things.
Okay.
That's what they do.
Okay.
It's all they do. They're not.
Yeah. So I think there's a question on the chat, Benedict.
Right.
Max. Yeah.
I'll read out the question. The beginning of the course is on propositional logic. Will we be interested in any overlap with topics like axiomatic set theory? We will be learning something that is. So what we will be doing is this computer proof assistant Lean that we will use. It's based on something called type theory, which is different from set theory. It's more structural in the sense that we are not concerned with building, with defining operations such as intersection or the union of sets or something like that. This will be operations that are given to us axiomatically. In that sense, it's kind of axiomatic, but it's more like axiomatic type theory than axiomatic set theory. So the basic objects will not be sets; they will be types, and types have elements, so that it's very or terms where they have inhabitants. So it's kind of similar to set theory, where some things are elements of other things, but the underlying the formalism is different, and it's more geared towards programming. So the answer is no, not really. There will be no set theory, but there will be sort of a foundation of mathematics that we will discuss in the course of the course. Yeah, during the course. Does that answer your question a little bit, Max? Okay. Any other questions?
Or comments?
Comments, suggestions? If there's anything that is missing also to the course, or any communication facilities or something, then please feel free to suggest anything. It's probably likely is that we just didn't think about it, we didn't reject it or anything, but please do shape the course also to your liking.
Yeah, I get a general question. Coming from quantum formalism, right? Is anybody using these kind of techniques to validate like quantum computing algorithms?
I don't know off the top of my head. I don't know. Could well be. In principle, there is no obstacle to doing so, but you would have to teach the computer proof assistant the tool first about quantum technology. And then, so you would have to formulate what it means, what quantum technology can and cannot do, and then you can start reasoning about quantum programs.
So this could be like a classical type of a verifier for a quantum computer, I guess, something like that.
Yeah. So it's a great question, and I don't know. I would have to do a search myself. I would type into Google. I would type quantum computation computer-proof assistant and see what pops up.
Yeah, because if not, this could be a rich area.
Well, this could be a project, the thing, a project by itself. Exactly. That's one of the reasons, because quantum computation is a whole new paradigm, emerging, and these things. And a lot of these questions haven't been actually asked, or people who are not, or maybe they're being asked, but nobody is, bothering to answer them because, the field has other priorities and these things, yeah. So we, for example, we are certainly interested in verification. For example, to verify that, for example, in the case of security, for example, that actually a quantum computation is actually being done by the actual quantum computer that you send your stuff to execute in, for example. So this is verification, some sort of verification stuff that it hasn't been fiddled with, And I assume also you can also ask the question, the right question that you ask when it does a computation. Is that computation correct? This is also a security question, but it's a very important one. Yeah. So yeah, it's a good question. Maybe this could be a part of your part of the project. It doesn't have to be like and it can be even, by the way, the projects, maybe we will be flexible. They don't have to have like some like implementation type of stuff, or like it could be also theoretical in nature, I guess. Some of the stuff, if you learn some of the theoretical stuff that you learn and, can go and, formulate some, come up with some interesting solution, theoretical stuff, that can also happen. But if you can actually translate it into a toolkit, even better. Yeah. So, yeah, good question. Yeah.
Okay. Anything else? Any other comments, questions, suggestions?
Let's see. Any other? I had the impression that I had something I wanted to say, but I forgot. Yeah, but it doesn't matter. If I forgot, it's probably not that important. And I can always share it on Zulip. The start date. That's it. The start date. I was going to send a survey. I think Benedict and I, we had some sort of a rough idea, but then we wanted to send a survey or something. But there aren't many people here at the moment in this Q&A. Maybe I can send it later, or maybe we can do it via Zulip. I don't know. What's your preference, Benedict? Maybe Benedict, you can suggest the ideal time starting for you, and then people can vote or something.
Right. I don't have a preference for when to start. Essentially, what I can do is I can prepare the material. If I go back to here, I can prepare these weekly plans, and then everybody can get cracking whenever they are ready. And then it's just a matter of scheduling the synchronous sessions where we discuss certain, and we have to agree on what to discuss at what moment. So one idea could be, I can inhabit this very quickly, at least the first few weeks, and then say we schedule the first synchronous session towards the end of May, sometime 2022 May or so, and then see how it goes for everyone, and see how much time people need to cover what I consider to be a 1 week quota. And if people need more time, then we can go slower, and if people are faster, then we can schedule the next the meeting for the second week. But we can leave 1 week or 2 weeks between each meeting. I'm very flexible. Yeah. So
yeah,
I'm not sure what exactly it is. Maybe we can do something like, as soon as a sufficient number of people said that they have looked at the content, they have studied a sufficient amount of the content of week X, then we schedule a meeting to discuss the contents of week X.
Actually, that could be it's a good idea, just to have a rough idea how many. Yeah, though we don't want people to be dragging their their feet to stop others, right? Because people's
yeah, that's right.
Human nature. We all do that. Even myself.
There is a risk that that will prolong the story for too long. Well, we can always, we should. It's difficult to judge how difficult the material is. Well, it depends on your background, and I'm certainly flexible. And we could say we meet either every week or every other week, depending on how many people say that they have already been able to invest sufficient amount of time into the material.
Yeah, one of the things that I want to comment, I think Benedict already alluded to it, is that we have like a starting point, the way the course will start, but we are very flexible to adapt based on the thing. Like Benedict, for example, was saying about the number of weeks, the number of that could change based on the thing, but also that's also in function of his availability as well, because he does have other commitments like conferences, and on that actually that could also be a good thing, because especially in the hardest part of the course, it will be very helpful if instead of 1 week gap, maybe 2, if Benedict is traveling to go for a conference or something, so that's one of those things that could actually play in as a good thing in the course.
Yeah, exactly.
Yeah, so definitely, I think towards the end of May could be a good starting point. In the week of the 22nd, it doesn't have to be on the 22nd, because I know Benedict is not available on Mondays. Mondays and Fridays, was it? Or Tuesdays?
Yeah, I'm not available Mondays and Fridays, but I think I'm available Tuesdays and Thursdays.
Yeah. So it could be the 25th, for instance. That could be if people are, happy on Thursdays. For instance, yeah. But
maybe closer to the time we can do a doodle or something.
Yeah.
Benedict, is this a good time of day for you?
That's a good question.
This is a reasonable time of day for me. Earlier is also possible. Later is also possible. It depends a bit on the. I mean, not a bit. It depends a lot on the time zones of the people who want to participate.
Right. There are 2 or 3 people in my area that participate in these programs. And right now it's around midday. It's lunchtime, which is actually pretty good for us.
Yeah.
I'm semi-retired. George is retired. A couple of the other guys are available, like Barry, whatever. And I know it was a decent time for Bamboo Day, because what's it, like 5, 6 o'clock in England right now? So,
yeah.
And you're in Holland. What time zone are you in?
Well, this is Central European summertime right now, so it's 7 p.m. right now for me.
1 hour ahead of us, ahead of UK, yeah.
So that's a good time for me. No problem. But it would be maybe too late for someone joining from India. I think depending on where you are in India might be different, but I think at least in some areas it's about 3.5 hours. So then it would be 10:30 in the evening. That could be too late. But I guess we should just see who is actually committed to attending the course, and then do it in function of those people.
Okay.
Yeah.
But this time is, for me, this time is convenient. It's one of the convenient times.
Yeah. Maybe you could start with it as a default to start with, and then adjust like 5 this time, the time we started, and then see. Yeah. And a lot of people also they will one of the things that I've asked Benedict whether the asynchronous session can be recorded. He's fine with it, but some people might not be fine with being recorded. In that case, maybe we just ask to turn off the video or something and be interactive before you join. Yeah.
So I should say that during the synchronous sessions, I would really like the participants to present their solutions. It's not my intention to talk a lot myself, unless there are questions that I should answer. But it's really, I see my role as moderating a discussion between the participants and injecting some expert knowledge, maybe if I have any expert knowledge to contribute. So the fact that, the question of recording something like that, I don't want this to inhibit people from participating in the way that they would otherwise participate. So we need to wait. We need to strike a balance between encouraging participation on the one hand and
for me, definitely participation is important. The recording stuff is as much as I would like to catch other people who cannot attend, but then if those people are making the effort to attend the sessions, and then because of the recording they feel like they hold back because they are maybe shy of making a mistake or something. Okay, we can decide on that. If somebody is presenting, if they don't want to be, we'll just stop recording. We'll participation is important.
Okay. Well, if there are no more questions, or are there more questions? Did I?
I guess there's also the possibility of, if you're not available, Benedict, of groups of us starting our own study groups. We did that before in courses.
Mm-hmm.
And then we can set our own rules about recording or not recording and that kind of thing.
Absolutely.
I think the study group can be like a good supplement to this, to the thing, even especially before you show up and have the session with Benedict. You can organize yourself in groups and go through the thing amongst yourself, and then go to Benedict.
Yeah, and I think this chat software, Zulip, it's very flexible. I think everybody can make new streams here. Everybody should be able to make new streams, and I think one can even make private streams. You can choose between private and public, and so if you have a buddy with whom you want to discuss, and you don't want everyone else to see your thoughts that are still evolving or something, then just make a private stream and discuss with a few buddies, and then come to a public stream to ask any questions that you want to share with everyone. So do use this software, I think, for also for your own studying. I encourage you to do that.
Yeah, definitely. I think
it's very important to ask questions and to answer questions. If you know the answer to a question, or if you have had the same question, then just react and be active, I think, in this Zulip channel. I think that would be very, very useful.
Yeah.
Okay.
Okay, good. I don't see any... Yeah, go ahead.
I was suggesting, if you don't have any questions now, but questions pop up later, then just put them in Zulip and we will respond.
Okay, great.
Yeah. Okay, good. So, thank you, Benedict, again, for taking your time to be with us. And good to see you all, everyone, Bob and Max and everyone. And let's get started. And, I look forward to seeing, people join, and most importantly, see it through, and and I look forward to it. It's a pleasure again to be with you, and we see you all next time, maybe in the next stream. Okay, I'll stop recording now, and then I'll stop the call. Thank you, everyone.
Thank
Thanks,
you.
Benedict.
Have a great day.
I
Bye.
look forward to this course. It sounds interesting.
Well, you will see more of these. It doesn't mean we are abandoning the mathematical side. In fact, I just want to comment, there is another one coming after this course on Lie groups and representations. So there will be more courses, but also we are emphasizing a lot on practical stuff as well. Yeah.
Okay.
So I think someone is asking to join. Unfortunately, this thing is about to end. I will just admit them and tell them this recording is about. So if you are just joining, I think maybe the time zone thing tricked people. I see
Claudia.
Claudia joining. Claudia, the UK time zone has changed. So it's the old 5 o'clock is now is now 6 o'clock, I think, isn't it? Because we have gone.
Yeah.
Me too. I'm a bit confused. So yeah. So we have just finished. Claudia, I don't know if Benedict has any flexibility. If you have any question you want to ask, but yeah. Okay, glad. Okay, yeah. Yeah, so I did in GMT, so it was 5 o'clock. Yeah. So I thought you have mistaken and joining at 6 o'clock, thinking it was BST. Yeah. Okay. Yeah. I think we are done. So we just ended now. The recording will be available on YouTube. Unless you have any specific question that I can answer. But I guess, after you watch the video, most of it will be. Yes, we can. In fact, this is one of the reasons. Yeah. I don't know, Benedict, if you want to comment, or I'll just refer to her to watch again the thing.
Yeah.
It's been designed to be asynchronous.
Yeah. Asynchronous is very possible. It's also possible to join the synchronous sessions, but if you don't have any time, then I think all the materials and a lot of the information will be available online. And you should. I encourage you to use the Zulip chat to ask any questions that you have during your study, and then hopefully your study buddies or I will respond. So yeah, it's definitely the goal is to make it doable, to optimize it for asynchronous participation. Yeah. Okay.
This is one of the reasons. Yeah. So Benedict, I won't take much of your time. We'll end here, and if anyone else have any questions, just watch the replay, and we will just feel free to ask any questions. Yeah. Okay. Thank you, Benedict. Sorry. And
Bye-bye.
we see you next time.
Bye.
Yeah. I'll see you.